Welcome learner, Department of Collegiate and Technical Education has provided us online teaching and learning platform through LMS. Under this program, we take up the course PCB Design and Fabrication Lab. Subject code is 15EC 56P for 5th semester Diploma in Electronics and Communication Engineering students. Under this Unit 1 PCB Design Flow, Session 4 now. PCB design process, PCB design flow, schematic design, design rule check, convert to PCB design is the first stage in the PCB design. First we have to capture the schematic, whatever the schematic diagram as given in the circuit diagram, then we have to put the design rule check or electrical rule check, then convert it to PCB. Then second step is create the board outline. Based on the dimensions given in the board outline, we have to create the PCB board outline. Third one, placing the components. Then routing and again put the design rule check or electrical rule check, which will check the pad to pad spacing, track to track, wire to wire, wire to pad, such things. Once the design rule check is over, it is cleared, then go for Gerber generation. Gerber file is the soft copy of the output file which is given to the manufacturing the PCB. PCB design flow, again toner transfer using heating method. Once the soft copy has been given, films has been produced, then it will be given to the PCB manufacturing process. Etching printed PCBs. Etching of the printed PCB is done in the manufacturing section and it is not in the PCB design center. Then once the etching has been completed, then go for drilling. Once the drilling also completed, then mount the components, then soldering the component, then final testing of the circuit output. PCB component placement. PCB component placement. After estimate has been made, a more detailed component layout can be made for the PCB design. Once the PCB cost has been estimated, if it is okay for the designer or the engineer, then he has to go for the PCB design. Consider aspects such as proximity of devices that may need to communicate with each other, changing of the component, changing of the PCB parameters that can be communicated between the engineer and PCB design engineer. Whatever the changes has to be done in the PCB, both should be communicated properly. Include relevant information such as footprint for the printed circuit boards, pads, any drilling information, keep out areas for PCB design. Drilling information, keep out areas and board pads, all those things has to be discussed with each other and has to decide take the final decision. Steps involved in the layout to design. Entry of schematic diagram is the first stage in the PCB design process. A schematic diagram provides the functional flow and the graphical representation of an electronic circuit. The entity of the schematic diagram is the first step in the PCB design using a CAD system or using a CAD software. The schematic diagram consists of electrical connections, junctions, integrated circuits symbols. Integrated circuit symbols and component symbols are involved in the schematic capture process. In schematic capture, connections are made to the symbols of the component and not to the actual footprint of the component. Entry of the schematic diagram. Input-output connections, or input-output connectors. Input-output connections are given to the input and output connectors. The PCB design engineer has to communicate with the circuit designer about which is the input connector and which is the output connector. Power and ground symbols. What is the specified power and ground symbols required for the engineer? The PCB designer has to clarify with the engineer. The ground may be an analog ground, the ground may be a digital ground. The analog ground and digital ground symbols are different from one another. Bus routing. What kind of bus routing has to be done in the schematic capture has to be communicated with the engineer. The engineer will suggest local in, local out connections are okay for him. Then the PCB designer has to follow the such kind of connections. If the engineer wants direct connections between the input and output directly, he need all the connections should appear in the schematic diagram. Then PCB designer has to follow that one. No connection symbols. No connection symbols should be provided or not, that should be cleared by the engineer. Reference names. Reference names should keep at the top of the symbol or bottom of the symbol has to be clarified with the engineer. Text. Where text should be placed in the schematic diagram, as that information has to be collected from the engineer as well as the customer who will going to use that end product. You have to clarify with them and put the text. If the board is designed for ISRO, the board, whatever the ISRO people will suggest the text in their schematic diagram, the PCB designer has to place that text in the schematic diagram of the ISRO PCB. Entry of schematic diagram. This is the schematic diagram menu. In this schematic diagram menu, schematic has been captured. How the bus connections are made, you can easily see the schematic diagram. An engineer can easily read this diagram and he can make that the connection is the bus connection. For normal connection and bus connection, there will be a difference is there. While seeing the schematic diagram, the engineer can make out this is the bus connection and this is the ordinary connection, this is the control connection, and these are all the command signals. Placement. PCB component placement. Before processing with the detailed PCB design and layout, it is necessary to gain a rough idea of where the components will be located and where there is sufficient space on the board to contain all the required circuitry. The PCB designer has to collect the information where to place the connectors. The one of the thumb rule followed in the PCB design placement is connectors, switches, LEDs should be placed at the edge of the board, and side tuning potentiometers should be placed at the edge of the board, and top tuning potentiometers can be placed wherever nearer to the component. And such guidelines has to be followed while capturing the while designing the PCB placement. While making the placement, certain thumb rules are to be followed, and which is the nearest connection that has to be followed. This will enable decisions about the number of layers needed in the board and also whether there is a sufficient space to contain all the circuitry may need to be made. If the PCB consists of more number of layers, the wires should be placed near the FPGA or the Spartan IC or the BGA contained in the PCB. Therefore, the space has to be provided sufficiently around the PCB to place the decoupling capacitors as well as termination resistors and also for placing the wires. This is the placement of the double-sided PCB. How the placement has been done, you can easily have a look over this. The components are placed by giving the sufficient space between each component. The component outline should not touch the other component outline. That is one of the main thumb rule has to follow while placing the component. And connection should be nearer connection and should not be twist cross connections. This is the printout given by the engineer after the placing the component. Once the placement has been completed, we have to give the reference PCB or wherever the components are coming in your layout has to given to the engineer. He has to cross verify this and he has to check and finalize this placement. Then only PCB designer has to go for routing. The next stage is routing. The next stage of the PCB design is to route the connections between all the components. The PCB design software then routes the physical connections on the board according to the netlist from the schematic. Whatever the netlists are given present in the netlist, those nets will appear in the PCB layout. Other than that, none other nets will be available. If other nets are available, means that is error. To achieve this, it will use the number of layers that are available for connections, creating via holes as required. The number of layers and via holes are required in the PCB is also plays a major role while routing the connections. If the vias are required, then only we have to drop the via. Otherwise, we have to try to avoid dropping vias. And while increasing the number of layers also, we should think twice and increase the layers. If you increase the layer, number of laminates will be increased. Again, the cost of the PCB will be doubled. Not only does this reduce the level of noise, but it enables low source resistance connections to be made for the power. When you increase the number of layers by providing ground and power planes, it not only provide low source resistance connections to be made for the power, and voltage drop will not be happen. And whatever, if it is 5 volt, exactly 5 volt will reach us to the destination. Routing. This is a proper kind of routing has been employed for the single layer board. Library manager. Library manager is the library which consists of all the components available for the PCB design. The library manager contains all the files for the component footprints. These footprints are used to design the PCB. The layout provides the facility to create a footprint library for component footprints. Libraries also contain a variety of symbols that you can use in your boards. That is for schematic capture. The layout has more than 30,000 footprints. Most of the software consists of more than 30,000 footprints. The components required for the PCB all are available in full version, but demo version consists of lesser number of footprints. Footprints refer to the physical description of the component. The actual physical dimension of the component is given by the footprint. See, this is the symbol has been provided for the IC. This is the actual footprint of the IC, and connection between the footprint and symbol has been made like this. This is the symbol name is matched to this is the footprint name. Checking routines are used to check that the design is fully in accordance with the specified standard. While checking the PCB, has to check the PCB whether it has followed the complete standard or IPC standard or not. Check parameters can be rules on spacing, minimization of number of plated through holes, special design rules, the current carry capacity of the conductor, opened or disconnected pins, positional errors. All these things should be checked while checking the PCB. If these all the errors are cleared, then only the PCB designer has to go for final printout. The errors are indicated on the display by flashing and can be corrected by the designer's interaction. The designer interact by giving the different colors to the different errors. Then he can identify what is the actual error is. Checking. After completing the design of the printed circuit board with the help of CAD tool, a designer again has to verify the PCB in order to find out the errors. Once the errors has been cleared, all has been checked, once again the designer has to check these PCB by using one more CAD tool. Such a type of verification design rule checks contains general verification, physical verification and electrical verification. And the PCB has been designed by one person has to be given to the another person for checking purpose is best method of solution for reducing the errors. Questions now. The first stage in the PCB design is A. Component creation, second schematic capture, third placement, fourth routing. The answer is schematic capture is the first stage in the PCB design process. Questions now. Question number 1. The first stage in PCB design is A. Component creation, B. Schematic capture, C. Placement, third routing. The answer is schematic capture. Second question. The assembly drawing is useful only component creation, while testing the PCB, after manufacturing the PCB, while soldering the component to the board. The answer is D. While soldering the component to the board. Third question. Routing power tracks in thicker track is also can be made by providing A. Coaxial cable, B. Wire, C. Planes, D. Shielding. The answer is C. Planes. Fourth question. The errors in PCB can be checked by A. DRC, B. ERC, electrical rule check, C. Placement, D. Both A and B. The errors can be checked. It can be called by design rule check or electrical rule check. Therefore, answer is D. Both A and B. These are all the references for the slides. Thank you for watching.